Hello. Hi, Kirtana.
Hi, hi, sir. Good morning.
Good morning, Kirtana. How are you doing?
I'm fine, sir. How are you?
I am doing great as well. Thanks for asking. So, how was your weekend?
It was nice.
Okay, good. Hi, Siddharth.
Hello, sir. Good
How are you,
morning.
Siddharth? Good morning.
Sir, I'm good, sir. How are you, sir?
I am doing great. Thanks for asking. How was your weekend?
Sir, it was very good, sir.
Okay. So, did you go through the recording?
Sir, I actually hadn't received the recording, sir. Where was it sent?
I
Was
sent.
it sent to my
I sent
father's
it to
number?
your. No, no. I sent it to your email ID.
Oh, oh. Mhm.
Yes. So, if you can check your email, uh, and tell me like if you received it,
Sir,
that will be good.
I
Yes.
still haven't received it, sir.
Okay. So I sent you the first day's recording. That means like we had three classes.
Yes, sir. Yes, sir. The first recording you had sent.
Do you have it?
Yes, sir. The April 28th recording I have.
Yes, yes. The others I have to send you. Okay, so I will send you the other 2 days recording plus today's recording. That means you will have totally 4 days recording. Okay, I will do
Yes, sir.
it right away after this call. So you go through the first week's recording. Okay,
Okay,
that
sir.
means day one, day two, day three of week one. Okay. So you can
Sir.
do that. And if you have any questions, please do ask me.
Yes, sir.
Okay. So any sort of like confusion or something like we uh, had some discussion over last week, correct? So do you have anything to ask?
No, sir.
No, sir.
Okay.
Uh, sir, after I visit the all the three links, I will ask sir.
Okay. Yes. So make sure that you spend some time reviewing this like recording. So see, I would personally tell you that this is a good opportunity to learn something, right? So you're just getting started on all these things. Okay. So you may be knowing something basic with respect to all these things, but like we are trying to understand more in depth. Okay. So please do visit these recordings and like, get some understanding more in depth, and we will have some hands-on programming as well. Okay. So we'll get a start on uh, those things, and later on like you can build something. Okay. So that is the format, and we'll go step by
Sir,
step.
sir, could you just repeat what you said, sir? I had some difficulty in my head earphone.
Okay. So what I'm trying to tell you, like we are going to go step by step, right? So foundation, okay, you already have, since like you have it in your school and in your curriculum. So you may know something. Okay. So what I am telling you, beyond basics. Okay, we are going to go beyond basics and learn something to like build here. Okay, it's just not like I'm going to explain you all theoretical concepts. So we will actually build something, and to build something, like you have to have some deeper understanding. Okay, so you will also have to code a bit. Okay, so you're not going to do extensive coding. Okay, at least you'll get started with respect to coding, and you will write some simple programs, train a machine, make it understand, then do the predictions. Okay. So I'm not going to like tell you about um, the interface, okay, where we are going to expose all this modeling. So that requires more time and more effort. Like, so we're not going there, but at least we will learn how to like train a model, test a model, all these things. Okay. So we are going to do this step by step. Okay. So with that said, let's give me 1 second. Somebody has come. Somebody has come. Okay. So I will just check with them like what it is and come back. Give me 2 minutes. Okay, I'm back. So let's start week number 2, day 1. I'll share my screen first. Can you just confirm? Are you able to view my screen?
Yes, sir.
What about you, Siddharth?
Yes, sir.
Okay. Yes. So in the last class, this is where we left, correct? Or like this is where we started. So now you understand what is machine learning, correct? So machine learning is something we are where you're teaching the machine to learn some patterns and you're not explicitly programming it. Okay, so you are making it learn through some examples, some data. Okay, so data is the foundation. Okay, if you have to build a machine learning system, make it learn, first you need to have the data. Okay, so once you have the data, then the next step is pre-processing, then training. So if you have to train, you have to have a model. Okay, so model is the brain of the entire system. So this brain gets trained on your data, and once it is trained on your data, it can perform some tasks. Okay, so that is your objective. So everything starts with data, correct? So data is nothing but anything that we observe, collect, and record about the world around us. Okay, simple examples, your name. So if I say Siddharth, that is some kind of information or data. Age of Siddharth is 15 years. That is some data. The marks that you score in your examination, that is data. Okay, so all this is required by the machine to learn something. Okay, based on which it can do some tasks. Okay, so overall, data is raw information. Okay, it is not something that is clean, it is very raw. Okay, like a vegetable. Okay, so vegetable, like if you have to cook, right? So you take the vegetable, you peel the vegetable, boil it, all these things you do, correct? So like a vegetable, data is pretty raw. Okay, you have to process it like you process any vegetable to cook. Okay, so it's a raw information that we collect before we do anything. Okay, we train, and based on the training we do something, we ask questions, we get insights, we get information, and then make decision. Okay, so that is what is our intention or our objective. So if we have to do this, we have to start with data, right? Examples, think of a fruit. Okay, so fruit like apple, fruit like lemon. Okay, so apple has got attributes. Okay, so when you say attributes, It has got color. Okay, color of an apple is red. It tastes sweet. Okay, lemon is yellow in color, sour in taste. Okay, all these are information about fruits, some kind of data. Okay, so this is what you need to collect. You need to input the model to learn something about the features of every fruit. Okay, so tomorrow, like let's say, like you show some picture to your model and ask what is this fruit. Okay, the machine should be able to tell what the fruit is. So that can only happen only when you have trained the machine with lot of other fruits photographs or images. Okay, so data is very important. Okay, why it is important? Computers cannot think like humans. It can only act based on some information you provide. Okay, so it will use the information to learn, and then based on whatever learning it does, okay, it gives you results. Based on the results you make decisions. Okay, so that is why data is important. Okay, now we discussed something about features and labels. Okay, so features are something like, like for the fruit example, you have color, size, shape, etc. Okay, so based on all these things only then you can tell what the fruit is. Okay, so if I tell you I have a device, okay, which is rectangular in size. Okay, it has like an LED screen touch. Okay, and it is used for calling, something like that. Okay, so I give you some information and I ask you like what is the device, then you tell me it's a phone. Okay, so phone is the label. Okay, that is the actual product. Okay, and when I say screen size, monitor size, all these things, it refers to its characteristics, it refers to its features, right? So overall data consists of features and label. Okay, so you can divide your information into two parts. Okay, features and label. So features are nothing but the characteristics of the item. Okay, example of a fruit, when you say apple, apple is red in color, round in shape, size, small, medium, big, whatever it is. Okay, so from all these things, you can make a machine learn. And if you have a new fruit, show the fruit to the machine and it is going to tell you what this fruit is all about. Okay, example I already told you. Let's say like farmers are like they are they have like all these fruits in their farm. Okay, and they are trying to harvest all these things. Okay, so typically they harvest in like thousands and lakhs. Okay, so each fruit that they grow, okay, it's just not like they grow hundreds and like few of these fruit in numbers. So they typically harvest in uh, thousands and lakhs. Okay, so when they have like typically a lot of fruits to harvest. Okay, they are harvesting and like they collect everything together and they'll have to segregate each and every fruit. Okay, so that's a big task if they have to do all by themselves. Okay, so lakhs of fruits and they try to segregate, put each of them into separate baskets. So that's not an easy task. Okay, so this can be handled by a machine. Okay, so if you say this can be handled by a machine, it has to be trained on identifying all these all these fruits. Okay, that means it should understand how an apple looks like, how orange looks like, etc. Okay, only then they will segregate all the fruits into separate baskets. Okay, so when I say segregate, they will pick up apple and they'll put it into one basket. They'll pick up orange, they'll put it into the second basket. Likewise, they will put each and every individual fruit into their respective basket. Okay, So that task is accomplished by a system here. Okay. So it is completely eliminating the manual intervention. It is saving a lot of time and it is efficient also. So as a human, when we do this particular task, like sometimes we mix up the fruits. Okay. So into the apple basket, we might put orange as well. Okay. So those kind of errors always do happen. Okay. In like when you train a machine to do this, okay, that error will be, or that particular mistakes that you make will be eliminated. It will be like eradicated. Okay, so you don't have the machine making those mistakes because it is something acting upon what you thought or what you made it learned. Okay, so it is just going to act based on whatever you made it learn. Okay, so in that respect, it is not going to like make mistakes. Okay, it is efficient, it is saving a lot of time for you. Okay, the same example, for example, let's say like you are sticking onto one particular fruit. Okay, so now you want to identify a fruit which is fresh. Okay, and it is not ripened. Okay, and you cannot throw away that particular fruit. Okay, so you're trying to check the condition of the fruit. Okay, so good fruit, bad fruit. Okay, that is what you are going to identify. Now this is the task. Okay, so you put all the good fruits into one basket and the fruits which is rotten or which is too ripen, okay, you put it into a different basket. If that is a task, the machine can do this task. So if that is a task, then it should have learned about identifying a good fruit and identifying a rotten fruit. Okay, so when it identifies a good fruit and when it identifies a rotten fruit, then it can pick up each fruit and put it into their respective baskets. Okay, so that is the task given to the machine and the machine can do. So here again, it is saving the like it is saving a lot of time of the farmers. It is automatic. It does not need any humans, any human support, any manual intervention. It is doing its job by itself. Okay, that is the advantage. Now model. Let's come to model. What's a model? As I told you, first you have the data, information. So information is processed. So after the information is processed, okay, now it has to go to a brain. Okay, so you'll have to build a brain around this data. Okay, something where you can input this and the machine learns. So when that is the requirement, the model comes in. Okay, so model is going to learn from your data. Okay, you have some upfront information. Now you input this model with information. Okay, so once you input the model with information, now it is going to learn something from the information. Okay, so once it learns, it can do your task. Okay, basically you are building a brain. Okay, where processing happens and learning happens. Okay, so model is a trained brain of a computer. Okay, so if you look at a computer, you have CPU. Okay, so without CPU, the computer is not going to function. Okay, so that is where processing happens. Okay, CPU is nothing but central processing unit. Okay, so whatever data is there, data gets processed there. Okay, so once the processing is done, then you have the result. Okay, so it is exactly like CPU of a computer. Okay, example, after learning fruits, the model can predict a new fruit. Okay, so you are making the model learn about different fruits. So when you have a new fruit, the model can identify what the fruit is. Okay, so that is what is your model. Now what is good data and bad data? I told you data is something that the machine gets trained on. The data has to be always clean. Okay, as I told you, data is always raw, correct? So like a vegetable, so if you have to cook a vegetable, you have to peel it, then boil it, wash it. Okay, then put it into a cooker, boil it, then ultimately if you want to fry the vegetable, okay, make a fry out of it. Okay, so that is what you're going to do when you have a vegetable. Now think data as vegetable here, as a vegetable here. So once you have data, you have to do some cleaning on this, right? You have to pre-process this. So the data always will have some inconsistencies. Okay, for with like the vegetable, you have this skin around the vegetable. Okay, so we cannot eat the vegetable raw. Okay, we'll have to peel that, right? So in the same manner, data has something inconsistent. Okay, something which is not required, and the model should not learn about all those things. That should be eradicated, that should be eliminated, that should be get rid of. Okay, so that is what you are doing in the pre-processing step. So once you have data, make it clean. Okay, so if the data is not clean, and if it has like inconsistencies present within it, then the model is also going to learn about those inconsistencies. Okay, so if you don't peel the vegetable, okay, so you are going to eat the vegetable with the skin, with the skin, right? So that is not what you should do, correct? So you should peel the vegetable, then cook the vegetable. Okay, nobody cooks a vegetable with its skin, correct? So they don't do it. So in a similar respect, if you think, you cannot use the data when it is raw. Okay, all this raw information has to be cleaned. Okay, so something with inconsistencies is called as bad data. Okay, something that is clean. Okay, you have pre-processed, you have removed all the inconsistencies like missing values, duplicates. The data is called as good data. Okay, model a model always needs good data. Okay, so you should not feed it with wrong data or inconsistent data. If you do that, then your predictions are going to be wrong. Okay, the results it is going to produce, it's they are going to be wrong. Okay, that's not what is the objective. The objective is to get accurate results. Okay, so that will not happen. And one more thing is bias. Okay, so bias is something that should not exist in your data. Okay, so what happens when there is bias? Okay, first of all, let's understand what's bias. Okay, bias is something that is unfair. Okay, so something that is one sided. Okay, so if you are teaching a particular machine, okay, let's say like you're teaching the machine about cats and dogs, you cannot have 9 pictures of cat and just one picture of dog and show this example to a machine and say learn about cats and dogs. Okay, so now if you show 9 examples of cat, 9 pictures or 9 images of cat to a machine and just one picture of dog to the machine, okay, the machine will understand the characteristics of cat more than dog, because dog has just one image, right? So if it has to learn about dog, okay, it may not be like it is not sufficient, it does not have sufficient data for it to learn. Okay, so it has a lot of information about the cat. Okay, so each and every cat is different, right? So it has its own characteristics. Okay, some cats are in like white in color, some dogs are in like black in color. Okay, there is variation, there is like there are different patterns with respect to cat itself. So it can understand all these variations of cat. Okay, but it does not understand the dog because it is just having one single example. Now in future, let's say like you're teaching the machine this way. Okay, and the machine, you feel that the machine will learn about cats and dogs. Okay, so tomorrow you show a picture of dog and you ask what is this picture all about, then the machine will tell you this is a picture of a cat. Okay, so even though you're showing a picture of dog, the machine still tells you it is a cat. Okay, so why it is telling you that the picture is of a cat? Because it learned about the cat much more accurately than the dog. Okay, dog because you just showed one example and you showed 9 examples of cat. then it has learned about cat much more efficiently, much more better than the dog. And once you show something that it has not seen, it is still going to give you some answer. Okay, so it needs some answer, it has to give you some answer. Okay, it cannot tell, or it will not tell you I don't know. Okay, it will not say unknown. Okay, it will only tell you cat. Okay, so if you have to get rid of this bias, okay, one-sidedness, then you'll have to have the data distribution in equal. Okay, that means you show 5 examples of cat, you show 5 examples of dog. Okay, that means it learns about cats and dogs equally. So in future, if you show an example of a cat, then it will identify that particular example of that particular photograph of a cat as cat. If you show a dog, then it is going to answer you back saying that this is a dog. Okay, so it learns accurately. Okay, if the data is imbalanced, okay, the data is not balanced. Okay, so it is not going to learn the way you want it to learn. Okay, so that is what it is. Example, train only on apples. Okay, so if you have to if you train the machine only on apple, AI thinks, or the machine thinks, that everything is apple. Okay, so there is bias. That should not happen. So if you show an orange and ask what is this fruit, it is still going to tell you apple. Or if you show a banana and ask what is this, it is still going to tell you it's a apple. It's an apple. Okay, that should not happen. Okay, so let's see this with an example. Okay, I will show you one live example. Okay, so here if you see, I have some students marks. Okay, so in this example, if you see, you have a student called us. One second. Okay, so if you see in this example, you have student Rohan, Mary, and John. Okay, so they typically study for their examination. Okay, every day Rohan studies for 8 hours, Mary studies for 9 hours, John studies for 10 hours a day. Okay, so when they studied for 8 hours a day, okay, they scored 90%, 90 percentage in their final examination. Okay, Mary scored 95 percentage in the examination. John scored 98 percentage of marks in the final examination. Okay, so now this is what we are making the machine learn. Okay, so now based on whatever it has learned on all these examples, if you ask the machine, okay, what is the marks secured by each and every student. Okay, so you input the number of study hours. Okay, and you ask what is their marks. Okay, so what is the machine likely to tell you? Okay, so this is an exercise for you. You tell me, okay, what is the machine will likely to tell you. Okay, so for Rohan, okay, you made it learn that Rohan studies for 8 hours. He secured 90 percentage in his examination. Now you are asking the same question to the machine. Okay, so Rohan studied for 8 hours. What is his marks? Okay, what is it likely to tell? Any answer, Keertan and Siddharth?
So could you just repeat the question once again?
Yes. So you trained a machine, right? So you trained a machine on this particular sample, right? Rohan
Yes.
studied for 8 hours, marks 90. Okay, that is the mark secured. Mary, 9 hours, marks secured 95. John studied for 10 hours, secured 98% of the 98% marks in his final examination. Now you're asking the machine the same question. Okay, Rohan studied for 8 hours. then what is the mark secured by Rohan? Okay, that is what you're trying to question. That means, let's say, like, I have shown three examples of cat to a machine. Okay, to, let's say, like, a kid. Okay, kid who is, let's say, like 5 years old or 6 years old. Okay, so when you show three different examples of a cat, the kid learns about these three different cats. Okay, now if I show the same example, let's say, like, after 1 day or 2 days, okay, I'm going to show the same set of images to a kid. The kid is going to answer something, right? So that is what I'm asking. In the same way, I showed some examples to the machine, okay, and the machine learned something. Okay, so I'm going to again repeat, or I'm going to ask a question, okay, on whatever it has learned. Now, what do you think the answer of the machine is going to be? Okay, I'm asking the Rohan has studied for 8 hours, and what is the marks secured by Rohan? Okay, this is what I'm trying to ask. What do you think the machine will tell me?
90 marks itself.
Okay, Mary,
90,
95.
John.
98.
90.
Okay, so why do you say that?
Because you taught the machine that way, using the same examples.
Okay, exactly. Okay, so it is going to say 90. Here it is going to say 95. Here it is going to say 98. Okay, so now I have a different student. Okay, so I have somebody called Mark. Okay, I am asking the machine. Mark studied for 5 hours a day. Okay, and what is the likely percentage of marks that he has secured? Okay, that is the question I'm putting up to the machine. Now, what do you think the machine is going to tell?
75.
Sorry.
75.
Yeah,
Okay.
75.
Okay. Alice, 4 hours,
70.
70. John,
65.
okay. Jason, 2 hours.
60 just.
60.
Alan just studied for 1 hour a day.
55.
50. 50.
Okay, whatever, 50 or 55. So now, why do you think the machine will give these answers?
Because the hour time that they studied was less.
Okay, what do you think? Say that.
So with the data given, it will understand that for studying more hours will result in studying, like, getting more marks. So the students who are studying less than uh, the students given here will score less marks than them. And so, like, if Rowan studied for 8 hours, he scored 90. Mark studied for 5 hours, so he will definitely get less than Rohan's score.
Mm-hmm.
So I
Okay.
so
No, the machine is going. It is not going to reply you this way. It's not going to give you answers this way. Okay, because the machine was not trained on these things, right? So nobody thought it, saying that if somebody studies for 5 hours, somebody studies for 4 hours, 3 hours, 2 hours, one. Okay, so this is the marks they score. Okay, so it is not going to give you the right answers. Okay, it cannot figure out, like, if somebody studies for like let's say here, if somebody studies for 8 hours, they score 90. If somebody studies for 9 hours, they score 95. Okay, if somebody scores for 10 hours, they score 98. Okay, so that means we as human do understand that, right? So if somebody scores for more number of hours, okay, they would have learned something more, and they are expected to perform much better than the others who have studied lesser than you. Okay, as a human, we do understand that. Okay, now we are feeding these examples to the machine and we are making it to learn. Okay, so now if you see here, we don't have information like if somebody studies for 5 hours, what is the marks they score? If somebody studies for 4 hours, what is the marks they score? That information is not there. Okay, the machine is not naturally intelligent. Okay, it cannot think the way we think, right? So as a human, we do understand. Okay, if somebody studies for less number of hours, their performance will be low and they will secure less marks. Okay, we do have that understanding. That understanding is not there with the machine. It is we need to teach the machine that, right? So here that is not there. Okay, it does not know that. Okay, so if you don't give all those information, it does not have sufficient information to learn. Okay, so if this is how you're training the machine, okay, then it will undergo something called as bias. Okay, so it will say if Mark studies for 5 hours, he may score 92. If Ali studies for 4 hours, he or he or she may score 90. Okay, if John studies for 3 hours, he may score 95 or 90, again 91. Okay, here 90, here 91. Okay, so this is what the machine will be the machine is likely to tell you. Okay, because this is what it understood, right? So you said that Rohan studied for 8 hours, in score he scored 90. Mary studied for 9 hours, 95. Okay, beyond this, it has not made any learning. Okay, so if you expect the machine to have or to perform better, then you should also train this machine. Okay, you should also train the machine like this. Okay, and later on, here, let's say like you 10 hours, 8, 9, 10. Okay, so let's say 5, 6, 5, 6, 7, 8, 5, 6, 3, 2. Okay, so if you made the machine learn about okay different hours of study, okay, that means from if somebody studies for let's say like 2 hours and somebody studies for 3 hours, 4 hours, 5 hours, 6 hours, you have more information to teach. Okay, that means it will learn about each hour of study. Okay, if somebody is studying for 2 hours, then what is their performance? If somebody studies for 3 hours, what is their performance? If somebody studies for 4 hours, what is their performance? Okay, it has a clear information now. Now when you ask the same question or something similar to this, okay, so now if I ask this machine, okay, so here I am not taught this machine. Okay, so here I am not taught this machine. If somebody studies for 1 hour, okay, what is the performance? But if I ask the machine, okay, if somebody studies for 1 hour, it can give me the result because it has studied something very similar. Okay, so somebody studied for 2 hours and they scored 91. Okay, so it might give me an answer saying that 90 or 89. Okay, it is most likely to give this answer because it studied more information. Now it has got more information about students' marks. Okay, it can perform. So earlier case, it did not have much information and it learned only about those information. If that is the case, the machine will most likely give you repeated answers. Okay, it will give you a biased answer. Okay, so that is what it is. Okay, so this we will see with one more example. Okay, so this time we have the example of fruits. Okay, so example number one, I have apple. Okay, So I have different characteristics of apple. So when the color of the fruit is red, the size is small, the texture is soft, I'm saying the fruit is apple. Again, I'm saying if the fruit is red, the size is big, the texture is soft, the fruit is apple. Okay, I'm saying if the color of the apple is red, sorry, if the color of the fruit is red, size is medium, texture is soft, I'm saying apple. Okay, so now if I train the machine this way, okay, so I'm just training the machine about apple. Okay, now I'm trying to ask the machine, okay, this question. The color of the fruit is red, the size is small, okay, the texture is soft. Okay, so what it is likely to answer?
Apple.
Any,
Apple.
any guess? Apple. Okay, so if I say black, color is black, size is small, texture is round. Okay, what is the machine likely to answer now?
Will not be able to answer.
It will answer. Okay, it is not like a human, correct? So it will not say, I don't know, unknown. Okay, it will give
It
you
will give a wrong
what
answer.
it is.
It will say
Okay,
It
it will
will
apple.
still
it
give
will
you,
reply apple.
yes, it will still tell you what it has learned about, right? So it just learned about Apple. So it will just tell you the answer about the answer as Apple. Okay, so it is something similar to like how kids learn, correct? So if we teach them, okay, so if we teach them like how an apple looks like, okay, so we give them three different apples, okay, one size small, one size big, one size medium, okay, and tell them like how this how an apple looks like. Okay, so now they just know about apple. Okay, tomorrow if you show something that is similar to apple, okay, let's say like you show them pomegranate, okay, they will not say unknown, right? So they will not say I don't know, because they don't know how to answer, right? So they will only answer saying that this is an apple, because they just got to learn about apple. Okay, they even do not know how to say I don't know. Okay, so if you are somebody, okay, who is mature, okay, and who has seen about a fruit, okay, which is black in color, small in size, texture round, okay, then you will say grapes. Okay, so you will say grapes. Okay, if you are 15 years older, or somebody who's more than 5 years older, or 3 years older, okay, you will be able to tell that. But the machine or the kid will not be able to tell, because they just learned about one single pattern, or like these patterns. Okay, so if that is the case, they will give repeated answers. Okay, so that repetition is a bias. Typically it should tell grape. Okay, but it is not going to tell you it's a grape. Okay, it's going to tell you apple. This is something that is incorrect. Okay, so if you have to correct this, then what should you do? Okay, then you have to show this few examples like this. Okay, it's a grape. I'm just telling you. Okay, so I'm not saying this is correct. Okay, so now you see equal distribution. I have three different patterns of grapes, and I have three different patterns of apple. So now it understands about apple as well as grapes. Okay, if I ask you the same question now, okay, it will tell you grapes. Okay, so that is the difference. So if you don't teach the machine equally well, then it is going to mostly give you biased results. That should not happen. You should take care of this data set or the information that you have. Okay, second example. Okay, again uh, you're giving some examples to learn. Okay, so apple, yes. So first example, like you're saying the fruit is red in color, small in size, soft in texture. Okay, you're saying apple. Okay, again you're having a different uh, like different example. Okay, but the same fruit but with different characteristics. Okay, you have three different characteristics of apple and you're showing the machine this particular example, but you're also showing, okay, let's say like you're also teaching this particular machine about grapes. Okay, so you say that the fruit is black in color, the size is small in the size is small and the texture is round. Okay, you say that it is grapes. Okay, now if you ask the machine, okay, the same question or like similar question saying that the color of the fruit is red, the size is small, the texture is soft. Now what answer the machine is going to give you? Any guesses?
It's going to the apple.
Apple.
The first case apple. Okay, second case
Uh, grape.
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 grapes, is it? What do you think, Kirtana?
Yeah, grapes.
Grapes. No, it is not going to tell you grapes. It is still going to tell you apple. Okay, because you showed it more examples of apple, right? The
Oh,
similar
oh.
way. Okay, so
Okay.
just connect this with some real example. Okay, so again connect uh, this with, oh, what do you say, like if you give the same kind of information to a kid, right? So if you show three different apples and one single pomegranate, okay, the kid will learn more about apple because it has got more samples to learn, right? So it knows more about apples than orange or a pomegranate. After 2 days you go and ask the kid, okay, what is this? It is still going to tell you this is an apple. Okay, it has, unlike that, it does not have that learning capacity. Okay, so when you show only few examples, right, so it will not learn. Okay, see, overall, I can tell you model is something that is very immature. Okay, like a kid. Okay, it is not mature like an individual who is 15 years old or like 10 years old or 12 years old. Okay, treat this like a kid. Okay, it is just like a kid. How a kid behaves, right? So the same way the machine also will behave. Okay, if you show the machine, okay, less examples, okay, it will not learn. If you would have shown the kid, okay, more examples, okay, we already saw that, right? So if you would have shown the kid more examples, okay, like different characteristics of a grape or a pomegranate or an orange, then it will be able to make that differentiation because it learned about apple, it learned about orange, or it learned about pomegranate equally. Okay, then it can tell you the right answer. Okay, now it does not have enough information to tell you the right answer, right? So that is the only uh, difference here. Okay, so you should provide machine enough examples. Okay, so when you teach about something and when you teach about something else, you'll have to teach them equally. Okay, when you teach them only equally, it is going to learn. Otherwise, it is going to give you something that it has learned more. Okay, so I'm not see, most cases it is going to give you apple. Okay, sometimes it might give you grapes. Okay, this is highly unlikely. Okay, so I'm just saying like 1% out of 100. Okay, it might give you this result.
Sir,
Okay, so mostly it is going to give you apple and apple. Okay, in very few cases it is going to give you grapes and grapes, but it is not going to tell you grapes at all. Okay, because it does not know about grapes at all, or it knows about grapes in very less amount. Okay, or let's say like If it knows 100% about an apple, it learned 100% about an apple, it has learned just 5% about the grapes. Okay, if it learned only 5% about the grapes, then how you expect the machine to tell that this particular fruit is grapes? It is highly unlikely, correct? So it learned about apple 100%. Okay, so that is what it can give you, uh, give the answer as, right? So it is not going to tell you grapes. Okay, so am I making sense? Am I making you clear? Do you have any
Sir, I have a doubt,
question?
sir.
Yes.
So, like, suppose if the AI is like fed with like equal data, like about apples and grapes, like suppose three, five, and five, and if an and for an if a fruit of color orange is given with some like some size and some texture, what will the AI answer as the fruit, sir? Has been given equal data about apples and uh, grapes before.
Okay. So again, it is not going to give you uh, the right answer. Okay.
Yes,
So
sir. But
what you're trying to
will
tell
give
me,
the
like,
apple or grape.
okay, so I don't know, like, if I understood your question correct. So you have one more sample to show, right? So you're saying orange. Am I making sense? Like you have some
Sir,
characteristics
I
of
am
orange.
saying, sir, I'm saying that in this example, suppose here there are like you've given three examples of apples, no, sir, and the fourth
Yes.
is a grape. So, suppose
Yes.
two more of grapes is given, and uh, in the second part you've asked from the color orange with says the size is small and round texture. What will the result be, sir?
Okay, 1 second. Okay, so this one is correct. Okay, so I'm saying like the color is black, size is small,
Yeah.
texture is round. Okay, so in the
Okay.
second row, okay, what do you want me to put? Okay, color black.
Uh, yes, sir. Size maybe like size is small only. Uh,
Okay,
sir, if now in the second part of the this, sir, like not in this table, in the second table, suppose if I give for color orange, uh, size is
okay,
uh,
color
size is
orange. Okay, color orange. Okay, it is going to still tell you apple because it has not learned about this, correct? So it does not know what orange color is. Okay, now at least it knows what red color is, what black color is. Okay, it does not know about this color at all.
sir,
Okay,
but won't
so it
the
has not.
AI be but won't the AI be confused because we've given equal amounts of information about red and black. So how will it
Okay,
choose if a new color is being given?
okay, so it did not learn about this combination, correct? So black, orange, round. Okay, it did not learn about this combination. It just learned about this combination: black, small, round. Okay, so it can just tell you, okay, when this is the combination, then the fruit is grapes. Okay, so now it does not know about orange at all. Okay, see, there are cases when it might say grapes. Okay, but most likely it will say apple. Okay, so that again depends. Okay, so you have to check how the model responds. Most likely it will tell you apple. Okay, so it may tell grapes. Okay, the chances are very less.
Okay.
Okay, because it does not know this color, correct? So orange is, it does not know what this color is. Okay, it just knows that when the color is black, size is small, texture is like round, it is a grape. Or let's say like this is the, Okay, it just has this information, right? So if it finds a pattern similar to this, okay, if the color is black, size is small, texture is round, then it is grapes. Okay, if the color is black, size is big, texture is round, the fruit is grapes. Okay, or the the fruit is black in color, size is medium, and texture is round. Okay, then it is grapes. It just knows this information, beyond which it does not know. Now you have a new combination, right? Black, orange, round. Okay, so this combination it has not learned. Okay, so when it has not learned about this combination, most likely it will give you a biased result. Okay, I'm not sure how it is going to give you grapes because it has got no evidence saying that this fruit can be a grape, correct?
Yeah.
Understood?
Yeah.
Okay. See, again, it is some kind of programming logic, correct? So if you put a condition, if color is black, size is small, texture is round, and color is black, or color is black, size is big, okay, texture is round, the fruit is grapes. Okay, so it will revolve, or sorry, it will loop around this condition. Only when this condition is satisfied, the fruit is apple, right? So even if you do this programmatical way, okay, so programmatical way, this might tell you unknown because you would have programmed that way. Okay, so here it is going to tell you apple itself. Okay, so that is the difference between your program writing an instruction and writing or doing this the machine learning way, right? So here if you would have to tell if the machine has to like respond with the answer as great, okay, then it should have learned about that combination. Okay, black. Okay, so if this combination was there, okay, then it will tell you as grapes. Okay, so since this combination is not there, okay, it does not know about orange color, it is still going to tell you that this fruit is an apple. Okay, now it makes sense, is it?
Yes. Yes, sir.
Okay, what about you, Kirtana? Like, do you have any doubts?
No, sir.
Okay, so Kirtana, please be active. Like, ask more questions. Okay,
Okay,
so
sir.
all these are critical, even if it is silly, right? So no worries. You please make it clear.
Okay, okay, sir.
Okay, because you will do this activity. Okay, I will ask you to collect data, and I will ask you to train a machine and give the results. Okay, so when you collect data, right? So you'll have to collect data that is accurate. Okay, or you pre-process the data and you get rid of all the inconsistencies and you make the machine learn, and machine has to give you the right answers. Okay, so that is the activity that I'm going to give you later. Okay, now let's go back here. Okay, so this example I told you already. So now comes data collection. Okay, so we know that the machine has to have some data. Okay, so now we need to understand how we build this data. Okay, how we create this data, which we have to give the model to learn on. Okay, so we need to collect data from different sources. Okay, only then we are going to have some consolidated information which we can make the machine learn on. Okay, so this activity is called as data collection. Data collection is the process of gathering information that AI will learn from. Okay, example, taking photos. Okay, So let's say like you want to make the system learn about cats and dogs or male and females. Okay, then if you have to make the machine learn about male and female images, you will have to collect data, right? So if you have to collect data, then how will you collect data? You will take pictures of your mom. Okay, you will take pictures of your dad, your friends. Okay, so let's say like you have five friends, okay, who are like females, and you have five friends who are male. Okay, so you take the pictures of your friends, and you like collect this. That means you take pictures from your mobile phone, and maybe like you store this somewhere in Google Drive or something, and from there you can give the photos as the input to the machine, and the machine will learn about your male friends and female friends. Okay, five male friends, five female friends. Okay, then it can, let's say like tomorrow you show some unknown picture. That means a friend of yours, okay, about whom like you have not what is that? You have not learned the model. Okay, so you have not shown that particular photo of that person to the model, and in future you show them, and you ask like, what is this picture, or what is this image is of? Okay, whether it is of male or female, then it will give you some answer. Okay, so first you need to have this information. If you need to have this information, you need to collect it from somewhere. Okay, one example I told you, taking photograph. Okay, asking questions, survey data. Okay, so if you want to make the machine learn about marks, okay, so you may go and ask your friends like, what is the marks that you scored in the examination. Okay, so you collect it through any of the sources, maybe like you send them WhatsApp texts, okay, and they reply. You send this to 10 different people, okay, you ask them this question, everybody responds to this particular question. Now you have the consolidated information from each and every student. Okay, so once you have the information from each and every student, you make the machine learn about every student's marks. Then in future, if somebody gets so much marks, then what is the like pass or fail status of that particular student? Okay, that can be done by the machine. Okay, this is one example. Recording clicks, okay, user behavior data. So let's say like you are working on a website. Okay, you typically run a online store, and users visit your website for some kind of information. Okay, so behind the scene, okay, whoever visits your website, okay, you can record those particular users data. That means the IP address from where like these users are browsing your website, the location, okay, and how many times they are visiting your website, how many times they have visited your website. All these information you can collect, you can store it in databases behind. That means your website is connected to a database. Okay, all the information is collected in your database. Or let's say like you are having a form. Okay, so if somebody wants to know about you, they have to fill that particular form, and you will provide them information. Okay, so if that is the case, you collect all the responses from the users, and you store it in the backend. This data, whatever you have stored, that you can make a model learn, an AI system learn. And in future, if you have similar users, then you may like predict something with respect to these data sets. Okay, so that is what is your data collection. So earlier we saw that AI learns from data. Now the question is where the data comes from. Yes, so data comes from different data sources. Okay, it comes through the activity of data collection. Okay, So now how do we collect data? Okay, there are different techniques to collect data. One is manual data collection. That means you collect data manually all by yourself. Okay, that means there is some human effort. Okay, example, survey forms, writing marks in notebook, counting attendance. Okay, survey forms, as already told you. Okay, so you have a form. You give people to fill up this form. Okay, so for example, let's say like you want to get some kind of admission to your particular school. If that is the case, then how people will approach you, how people will get admission to your school. Okay, let's say like in 10th standard, okay, somebody wants to join, or let's say like there are a group of people who wants to come and join your school. They typically will be given an application form, and they will be asked to fill up that particular application form. Okay, so verbally they're not going to take the information. They will be asked to fill an application form. So if there are 10 people who are looking to take admission to your particular school or particular class, then they will fill these application forms, and somebody at the admin desk, okay, they will review all this information, and maybe like they will collect, or they will call back all the students' parents, and they will speak with respect to admission, like when to come, fees, and other details. Okay, all this information will be provided. So this is some kind of data collection. Okay, writing marks in a notebook. Okay, so you write down marks in a sheet of paper or something. Okay, so for example, let's say like in a class there are 50 students. Now all these 50 students write, uh, let's say like they are going to their class test or examination, and they're going to perform in their class test or examination. They write their examination or class test, and finally the marks are out. Okay, the teacher corrects their uh, like what do you say, like the examination paper or whatever, and ultimately you have the marks secured. So this marks has to be noted down somewhere. Okay, so the teacher, okay, can have a template. Okay, so there she can note down the marks. Okay, so that is some kind of data collection. Okay, she has the information, and she is putting this onto a register or a notebook where there is a template. Okay, so like Excel, you make a table. Okay, in the table, like you have the student name, marks in English, mathematics, science, all these things. For each and every like subject, you have different columns, and you can enter the marks there. Okay, so the teacher enters all these things manually there. Okay, so this is one act of collecting data. Okay, or she enters this in an Excel file. Okay, so if she is doing this digitally, then he or she is doing this in an Excel notebook. Okay, they are entering data. So this data can be fed to a machine learning model, and they can be uh, trained on these data sets. Okay, counting attendance. You count attendance and you make a note. Okay, so that is data collection. Second, automatic data collection. Okay, so here we're not talking about humans collecting data. Machines will collect data. Okay, so for example, Google tracking searches. Okay, so you go and browse Google, right, every day. So when you go and browse Google, okay, so in the search box, you're trying to search about something. Okay, so whatever you're trying to search, okay, that will be stored in the Google's backend systems. Okay, that means they have all their users' data. Okay, whoever are using their services, that means the browsers of Google, okay, Chrome or whatever. Okay, they are tracking all the search history of each and every user, what they are browsing, at what time they are browsing, how many times they have browsed on that particular search query. All these things they are recording. Okay, so in the backend system they are recording all these things. That means they're typically collecting data from the users. The same way YouTube also collects data from you, right? So whatever you go and watch in YouTube, okay, so they record that, they collect all those things. Okay, apps collect tracking clicks. Okay, so if you are using any kind of applications, okay, then the apps also are tracking how many times you clicked that particular app, how many time you entered within that particular app, you use their functionalities, features, all these things. The apps also are tracking the clicks. Okay, so this is again some kind of data collection. Third, sensors. Okay, so I think you typically have heard about some of the what do you say, like IoT devices. Okay, so I think you are aware of fitness devices like Apple Watch, right? So what Apple Watch does, okay, so when you have this Apple Watch on your wrist, and like you wear this on your wrist and you go out for walking, okay, or you go out for jogging, they will record the number of steps that you uh, the number of steps that you take when you walk a particular distance. Let's say like you walk 3 kilometers a day. So when you cover 3 kilometers a day, how many steps have you walked? This can be tracked. Okay, so now how they track? So within the smartwatch or within this Apple iWatch, there are sensors. Okay, that will connect to your Google Maps. Okay, and they will track the number of steps that you take to cover this particular distance. Okay, so that is some kind of data collection. Okay, GPS, again I told you, Google Maps, correct? So they will track your location, where you are going, okay, how long you're traveling. Okay, so all these things they will track. Camera, okay, so camera also record images, so that is also some kind of sensor. Okay, so camera in the sense like you take photograph, correct? So when you take photograph, it will tell you the location, okay, where it is captured, etc. Okay, so all this information it can give you, it can give you the location information. That means the latitude information, the longitude information, okay, the exact coordinates where this particular picture was taken. Okay, so it does all those things. Okay, so that is some kind of data collection. Okay, so now we have to collect data if we need to train a machine, right? So that is our intention. So when you collect data, you run into some kind of issues. Okay, so incomplete data. Okay, you may not have incomplete data. So which we saw in the other example of bias, correct? So when you train the machine with just one particular set of information, the machine will learn about only that particular set of information. That means when you teach a machine only about Apple, and tomorrow you give a you, let's say like you are trying to show an image of an orange, and ask the machine like what is this image all about, it may not be able to tell you that this is an orange, because you did not show that particular example to the machine. You just showed the examples of Apple. So when it learned just about apples, then how it is going to respond you back and say that whatever you showed me is an orange? Okay, it typically will not be able to tell you that, right? So that is not going to happen. So you need to have complete data if you are trying to test the uh, machine or the system with different fruit examples. Then train the machine with all those fruit examples, okay, in equal distribution. Okay, so if you have different characteristics of a fruit, okay, a fruit which is smaller in size, a fruit which is medium in size, a fruit which is larger in size, then you give all the variations to the machine so that it understands about each and every variation. Okay, so only when you train the machine on all these variation, okay, it can identify in future, if you show that particular example, okay, whatever variation you have shown, you have already shown, okay, with that variation, if you are going to test the machine, it is going to tell you that this is what the fruit is. Okay, if it does not learn about that variation or pattern, then it is ultimately going to give you a wrong answer. Correct? So either biased answer or incorrect answer. So that is what. Example, only five students answered, not accurate. Okay, if you just train the machine with five students results, then the machine is going to not learn about, or it is not going to learn much. Okay, it is going to learn just about those five students. So if you provide this particular machine with information of other students, then it is not going to respond back and say you this is what the pass or fail status of this particular student is, because it did not learn about that particular student. That should not happen. You should have complete data. Then biased data. Okay, so you should not have biased data. There should be equal distribution of data. Okay, so when you have different fruits that the model has to learn about, then give the machine equal distribution. Five examples of apple, five examples of banana, five examples of orange, five examples of grapes. Okay, so if you have equal distribution, the model is going to learn about the fruit in equal way. Okay, that means in future, if you show about these particular fruits, it is going to give you the right answers. Okay, a wrong data. So you cannot even give wrong data. Okay, for example, you have characteristics of an apple. Okay, that means the color is red, size is medium, and texture is soft. And this is the characteristics of an apple. And if you say this is the characteristics of a banana, the machine will think that this is a banana. Okay, so that is something wrong you are teaching to the machine, right? So the machine cannot learn wrong things, incorrect things. So that you should avoid. Okay, so whatever you teach, that has to be accurate. So this has to be done in the pre-processing step. Okay, so or like when you do the data entry itself, okay, you make sure that you do this correctly. Okay, so you inspect your data and you see like everything is accurate. So if that is not accurate, if it is not accurate, then that has to be corrected, right? So that is with respect to wrong data. Okay, so this we need to take care of. Okay, so we cannot have something that is incomplete, something which is biased, something which is wrong. Okay, we need to take care of all these things. Now comes the matter of data privacy. Okay, so when you collect information, right, so what should you collect and what you should not collect? Okay, so that also matters. See, when you train a machine, right, so you cannot train a machine on everything that is like everything that you have. Something might be private, something might be personal, right? So that information you should avoid. You should not use, and like you should not train those information. You should not train the machine on those information. Okay, should we collect everything? No, we should not collect everything. Okay, for example, personal data must be avoided, personal data must be protected. Don't misuse the data. Okay, for example, if you're collecting the information of students, okay, so typically students may not be in a position to give their phone numbers, or they may not be willing to share their location, or they may not be in a comfortable position to like provide their photographs, images. Okay, so when that is the case, you should avoid asking them this information. Okay, so you don't collect their phone number, you don't collect their location, you don't collect their photos. Okay, so not everybody is comfortable giving their phone number. Okay, somebody might be willing, somebody might be like willing to give their phone number, somebody may not be willing to give their phone number. Okay, somebody may share their photograph, somebody may not be in a position to share their photograph. Okay, and all these things are not even mandatory, correct? So you cannot say that you might want their photograph, you want their photograph desperately. Okay, that is not the case. That is something which is personal. Okay, so personal, you may not be collecting. Okay, so that you should avoid. So this is all with respect to your data privacy, right? So majorly, it talks about personal information. Okay, so you cannot collect something that is personal. Okay, so now we will see. Okay, so it is already 12:20, right? So I think this will take some time. Okay, so what I will do, I will cover this in the next class. Okay, so next class I'm planning to start Python. Okay, do some basic things with respect to Python. Okay, write a simple Python program and get started with Python. Okay, and let's say like we have data, how to work with some basic data. Okay, so that we will see in the next class. Okay, so before we start that, I will show you how to collect data. Okay, and also I have an exercise for you. Okay, I want you to collect some data, okay, of your choice. Okay, so before that I have to explain you like how you collect data, correct? So we don't have much time. Okay, so this will take at least half an hour. Okay, so we will continue this in the next class. Okay, so meanwhile, if you have any questions, please do ask me. Okay, I will try to respond to your questions. Do you have any questions, Siddharth and
So
Kirtana?
not right now, but I will look the recordings. I'll look through the recordings and I will message you. So
Okay,
Yeah,
no,
me too.
so that is fine. So whatever we discussed today, right? So we discussed few things. So whatever we discussed today, okay, on these things, like, do you have any questions?
no, sir.
Okay, so if that is the case, then fine. Okay, so we will try to meet on the coming Saturday. Okay, same time, 11 o'clock. Okay, so and we'll close out week number 2. See, my major interest now lies in Python. Okay, so Python is where like you're trying to build all these things, right? Now we theoretically understand what happens behind a machine learning framework, right? So theoretically, conceptually, we have some understanding. Now let's go and build this. Okay, that is my intention, and we will do it in the weekends. Okay, and one more thing, I wanted to tell you, right? So, like, when are your classes starting? Siddharth, you told me like somewhere in the last week of
First week of
May, correct?
first week of June. So
First
school.
week
You
of
can
June.
say.
What about you, Kirtana?
May 25th.
May 25th. Okay, no worries. So what I would tell you, like, see, I can even help you with respect to your curriculum, right? So Siddharth, if you have some practical stuffs, okay, that means you have something to do with respect to AI, correct? So you are going and building something in your curriculum, right? So you have labs also, correct?
Yes, sir.
Okay, and you're saying that you're finding it hard to understand those things, correct?
Yes, sir.
Yes. So if that is the case, you get in touch with me. Okay, I can help you out. Okay, so that is something. Uh, I'm not. See, that is something that is separate from this particular course. Okay, so if you want some personal help with respect to all these things, right? So you understanding how things are built. Okay, and you want me to help you with respect to these labs that you do in your school. Okay, I can help you along with this, like, this is something common to you both. Okay, let's say like, uh, Siddharth, you're in 10th standard, correct? So you're preparing for your board exams.
Yes, sir.
Okay, Kirtana, you'll be preparing for your board exams next year, correct? But I think in the ninth standard itself, they'll start 10th standard portions, correct, at the end of the
Yeah, at
uh,
the end.
at the end. Okay, so fine. So what I'm trying to tell you, okay, if you want some kind of help with respect to your science subjects, okay, like physics, chemistry, and biology, I can really help. Okay, that means if you want to understand some topic and whatever they are teaching in your school is not like helping you out, then please do reach out to me. I will make you understand in a clear way. Okay, so I can help you in that regard. It's a regard in that regard also. Okay, so do get in touch if you have
Yes,
difficulties
sir.
in that
Sure,
respect.
sir.
And see, I'm also planning to like set up a particular session like where I get students like you, right, clearing their doubts. Okay, clearing their doubts and getting the conceptual understanding on the science subjects. Okay, so majorly I'm focused on science subjects. Okay, so I'm not somebody who's into mathematics and like the languages, right? So I'm not focusing on that, but with reference to the science subjects, I can definitely help. Okay, and uh, I definitely feel that like these board exams that you go and write, right, they are competitive, right, and it needs some kind of preparation. Okay, so I think you're planning for some kind of tuitions and things, etc. Correct?
Yes, sir.
Okay, yes. So you can take a call on that. Okay, and let me know. I can definitely help. Okay, if there are somebody uh, who you want to bring on board, that is fine. Okay, I will take care of that. Okay, so that is one thing I want to tell you. And personally, also after this course, if you are interested to learn more, okay, so here, as I told you, right, so we're not going to do extensive things. Okay, this is just 1 month course, and you will have something, right. So you'll not be in a stage like where you go and build applications. Okay, so if you have to get to that particular stage, right, so you'll have to mature. Okay, so if you want to mature and if you want to get there, then definitely I can help you, but I'm not sure about your time commitment because your boards are coming up. So anyways, so you take a call on that as well if you need some help, and if you want to learn something that is really good for your future, I can definitely pitch in.
Okay, sir.
Yes, sir.
Okay,
Understood.
so fine, continue. Please carry on, continue. Please do like review all the recordings. I will send you that. Okay, so whenever you have time, so do that.
Yes, sir.
Okay, so thank you, Kirtana and Siddharth. Okay, I really
Thank you, sir.
appreciate your time. We will meet on this Saturday and Sunday.
Okay, sir.
Yes, sir.
Yeah, take care. Bye.
Nice.